Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. Our week 5 program is write a program to implement Vigenere Cipher. Vigenere Cipher is a substitution cipher. In the 19th century, the schema was misattributed to Blaise D. Vigenere and so acquires its present name. Vigenere cipher is a method of encrypting alphabet text. It uses simple form of polyalphabetic substitution. In polyalphabetic substitution, the same plaintext character will contain multiple substitution characters or ciphertext based on the key. The encryption of virtual text is done using Vigenere square or Vigenere table. The table consists of alphabets written out of 26 times in different rows. Each alphabet shifted cyclically to the left compared to the previous alphabet, corresponding to the 26 possible Caesar cipher. At different points in the encryption process, the cipher uses different alphabets from one of the rows. The alphabets used at each point depends on the repeating keywords. This is Vigenere table. In this table, we will write alphabets 26 times in different rows like this. The first row start with A, end with Z. Next, cyclic left shift operation is performed. The character moved towards left compared to previous alphabet row. So here it will start with A. Here we are shifting our alphabet cyclically to the left so that A will be moved to the last position. Now the alphabet starts with B. B, C, D, E, F like that, Z and A. Here A will be our last character. In the same way, next row will start with C and end with B. Next row will start with D and end with C. Like that, the last row will start with Z, end with Y. In this, the horizontal characters represents plaintext and the vertical characters represents key. Encryption algorithm. To generate ith character of ciphertext, ith character of plaintext is added with ith character of key and the result is mod with 26. It looks similar to Caesar cipher, but the Vigenere cipher is different from Caesar cipher. Caesar cipher is a mono-alphabetic substitution cipher. In this, key is fixed, that is 3, and the same plaintext characters are substituted with the same ciphertext characters. Vigenere cipher is a polyalphabetic substitution cipher. In this, the same plaintext characters are substituted with different ciphertext characters, depends on the key. Decryption algorithm. To generate ith character of plaintext, ith character of ciphertext is subtracted with ith character of key and the result is mod with 26. Now we'll see one example. This is Vigenere table and we are performing encryption. Horizontal rows represents plaintext and vertical letters represents key. Our plaintext is secure message and our key is Vigenere cipher. By using this key, we are going to perform encryption and we are going to generate the ciphertext. First, select first plaintext character and first key character. Our first plaintext character is yes. Find out yes in plaintext sequence. So this is yes. Here we have yes and find out V on key. Here we have V. Then find out intersecting character of this row and column. So N is an intersecting character. We are going to replace our plaintext character with this N. Next plaintext character is E and key is I. Find out E on plaintext and find out I on key. Then find out the intersecting character of the row and column. M is an intersecting character. So we are going to replace E with M. In the same way, C. Find out C in plaintext. Find out G in key. And intersecting character is I. So C is going to replace it with I. Next, find out U in plaintext and E in key. Find out the intersecting character, that is Y. So we are going to replace U with Y. Next, R in plaintext, N in key. And the intersecting character is E. We are going to replace R with E. Next, E and E. Find out E on plaintext and find out E on key. The intersecting character is I. We are going to replace this E with I. Next, find out M on plaintext and R on key. Intersecting character is D. We are going to replace M with D. Next, plaintext character is E and the key is C. So find out E on plain text and C on key. The intersecting character is G. So we are going to replace E with G. Next, the plain text character is S. Find out S on plain text and the key is I. Find out I on key. Intersecting character is A. S is replaced with A. Next plain text character is S and the key is P. Find out S on plain text and find out P on key. Intersecting character is H. We are going to replace S with H. Next plain text character is A. Find out A on plain text and H on key. The intersecting character is H. So A is going to replace it with H. Next character is G. Find out G on plain text. E on key. The intersecting character is K. So we are going to replace G with K. Next plain text character is E and the key is R. Find out E on plain text. Find out R on key and the intersecting character is V. We are going to replace E with V. In this way we will generate our ciphertext. We will forward this ciphertext to receiver. See here. In our plain text, S is repeated 3 times and E is repeated 4 times. So find out the characters. Observe the ciphertext character for the same plain text characters. First time S is replaced with N. Next time it is replaced with A. Next time it is replaced with H. In the same way, first time E is replaced with M. Next time it is replaced with I. Next time it is replaced with G. And next time it is replaced with V. So in polyalphabetic substitution, for the same plain text character, we will have different ciphertext characters depends on the key. Decryption is exactly reverse to encryption. Our ciphertext is this one and our key is Vigenere Cipher. By using this key, we are going to decrypt the ciphertext. To decrypt the ciphertext, first identify the ciphertext character on the key row and find the starting character of the ciphertext column. Now we will replace the ciphertext character with the starting letter of the column. For example, our ciphertext character is N and our key is V. Identify N on V row, here it is, and immediately find out what is the starting character of that particular column. So the starting character of the column is S. We are going to replace N with S. In the same way, next find out M on I row. I is here. Find out M. M is here. Immediately find out what is the starting character of that particular column. E. M is going to replace it with E. Next, find I on G. G is here. Find out I. I is here. Then immediately find out what is the starting character of the column. C. I is going to replace it with C. Next, find out Y on E. E is here and Y is here. We are going to find out what is the starting character of that particular column. That is U. We are going to replace Y with U. In the same way, find out E on N. E is here on N row and find out what is the starting letter of the column. R is the starting letter of the column. We are going to replace E with R. Next, I on E. So we find I and the starting letter of the column is E. We are going to replace I with E. Next, D on R. We identify D on R and the starting letter of the column is M. Next, G on C. So we identify G on C. The starting letter of the column is E. Next, A on I. We identify A on I and we identify the starting letter as S. So we are going to replace A with S. Next, H on P. H is here and the starting letter of that column is S. H is going to replace it with S. Next, H on H. H on H is here. The starting letter of the column is A. We are going to replace it with that A. Next, K on E. So K is here and the starting letter of that column is G. We are going to replace K with G. Next, V on R. V is here and the starting letter of the column is E. We are going to replace V with E. So we got our plain text secure message. In this way, the decryption is performed. This is standard program. In this program, I have written the logic for encrypting the plain text and encrypted plain text is forwarded to receiver. This is receiver program. In this program, I have written the logic for decrypting the ciphertext received from sender. Now we'll see how to execute the program. I have written two programs, one program for sender and another program for receiver. To execute these programs, open two terminals, one terminal for executing sender program and one terminal for executing receiver program. First, compile and execute receiver program. To compile the program, use this command cc space program name dot c minus o and new file name. To execute the program, call exe file vir.exe. Now the receiver is ready to receive the message. Next, compile and execute sender program cc space program name dot c minus o and new file name. Then execute the file. Here we are passing two arguments. One is IP address of receiver system, that is 127.0.0.1. Here I am using loopback address because I am executing two programs in single system. That's why I have to specify loopback address. If you execute these two programs in two different computers which is connected in a network, you have to specify the receiver system IP address and the receiver system port number. Now enter your message. Our message is secure message and our key is Vigenere Cipher. It is encrypted the plain text and it generated a ciphertext. That ciphertext will be forwarded to receiver. Yes, receiver got the ciphertext from the sender. Now we have to decrypt this ciphertext. To decrypt the ciphertext, we have to enter our key. Our key is Vigenere Cipher. The receiver system decrypted the message and we got our plaintext message, that is secure message. In this way we have to execute the program. You have to take these two challenges and solve these challenges. The first challenge is encrypt the below plaintext using Vigenere Cipher substitution. The plaintext is cryptography and key is intelligence. And the second challenge is decrypt the ciphertext by using Vigenere Cipher substitution, and this is your ciphertext and this is your key. Thank you.